Sassine, like a lot of focus on the company has been in recent weeks and months about the relationship with NVIDIA, right? But the point of the next 48 hours is to basically set out what happens next for you. A big part of that is you do this big deal with Ansys and you have to tell the world, well, how are you going to use that? What's the technology roadmap from here? So outline it for us.
First, thank you for the opportunity to explain the thesis behind the Ansys acquisition. The engineering complexity is compounding both at the silicon level, the chip level, as well as the intelligent systems, the AI-infused products. You hear companies talk about physical AI. How do you make that engineering task happens in a cost-effective way and tame that complexity in a timely manner? We're bringing together the silicon community, which is the chip design, with the physics of an end product together in order to deliver to that future. That's where Ansys leadership in multi-physics simulation, you need fidelity of the physics as you're creating a digital twin of that product and how to co-design it with the electronics part.
We have it on good authority from NVIDIA and Jensen Huang, like you're good at chip design. But I think a lot of people are searching for what other areas, business lines, products do you expand into beyond your history in the context of that acquisition?
Yes, Synopsys traditionally has been the enabler of chip design, both on the architecture side all the way into manufacturing. With the Ansys acquisition, it expanded our customer base dramatically. Actually, we went up more than 10, 11x in terms of our customer reach. If you think of an automotive OEMs, we are at more than 90% of the automotive OEMs using our software to both design the electronics and the physical aspect of the car, be it the structure, the fluid dynamics, etc. Now, the reason these two worlds are converging is driven by complexity. The complexity of these systems are going to be AI infused, where you have agents running a robot or a car or a drone. How do you design this complex multi-domain of engineering and co-design it by creating a virtual representation of it? That's what Synopsys with the Ansys portfolio brings into the equation.
AI makes it more complex. Many would say AI agents might be doing the design work themselves, might suddenly be looking at building digital twins. Talk to us about how you fended off some of the anxiety that software is going to be ripped up, the script ripped up by the latest, greatest agent from an Anthropic, for example.
Yes. So you step back and think about it. Software is everywhere and is in everything. What we do, the special sauce is not the coding of the software. The special sauce is the physics, the algorithm, the solvers, the fidelity of the solvers. Imagine you are a semiconductor company that takes you about 18 months to develop a chip, and you spend hundreds of millions of dollars just in the development phase of a chip. You cannot be good enough before you go to manufacturing. You have to be 100% certain once you finish the design and you ship it to manufacturing, the product is going to come back and is going to work. So that fidelity of physics, because at the end of the day, the software we build has to translate into a manufacturable product that's going to work. So this is where we're using AI everywhere in our products in order to bring an automation and a next level of simplicity and digitization to the workflow. But the key is the physics aspect of what our customers are doing and how we enable them to deliver to it.
So that's the moat. I'm interested as to just what your customers are feeling right now with supply chain angst, with logistics headaches, but also more broadly, they can't get their hands on the right things, they can't build them quick enough, particularly when we think about memory. How are you thinking about not just the difficulty in designing, but making sure that the yield is good enough to come up against what is a very difficult time?
Exactly. What our customers are facing, beside the supply chain challenges and the global stress that we're dealing with, there's a shortage of engineering. They cannot get enough engineers to deal with that complexity. So AI helps augment the existing engineers. The second aspect of it, reducing the cost. You can reduce the cost by improving the yield. Memory is a fantastic example. No matter how much the memory companies try to expand capacity by building factories, you need to be able to have better yield. That's where we come in to help them design the actual physics of manufacturing with the design phase to improve the yield. So those are the components, and reducing the design cycle. Traditionally, chip design was 18 to 24 months. Now you have customers like NVIDIA and other talking about the design rhythm of 12 months. That is not possible without injecting AI everywhere in the flow. And when you go to manufacturing, you're able to improve your yield.
Sassine, what conclusions did you reach in recent weeks after the sell-off in software names about the long-term definitive impact that AI will have on EDA? You're one of the biggest EDA names, right? But you're not the only one.
Yeah, unfortunately, it was a naive approach to say that all software is the same. You're going to have some software where LLMs, foundation models, yes, is a perfect application to, let me call it, replace. But when you look at the engineering software, I'll go back to the physics aspect of it. We run, we code, and we deliver software to our customers, but that's not the moat. The key differentiation are the solvers to translate from an architecture design to an actual manufacturing product. So I believe it was absolutely an overreaction by putting every company that delivers software in the same categorization.
Looking at Bloomberg Intelligence, they're looking positive on your longer-term operating margins, on the ability for Ansys to really provide profit lift. But just talk to us about growth in the here and now of the design IP business. Are you going to get to more than sort of low single-digit growth? Are we going to see a re-acceleration despite China being such a tough market right now?
Yeah, so we had a couple headwinds. One of them is China. China was growing for us at a 20+% CAGR over a period of about 3 to 4 years. That has slowed down for all the reasons that we know in terms of restrictions and export control. Now, despite that headwind, the proliferation of silicon design and the complexity of designing that silicon, it's giving us an opportunity in many, many regions and across the customer base, be it AI, HPC design, automotive, mobile, consumer, etc. Now, what we have communicated is we reinforced our long-term commitment to a double-digit growth in EDA, as well as IP in the mid-teens, and the Ansys portfolio is as well in a double-digit growth. And the reason for reinforcing that confidence and commitment is the massive acceleration in engineering and the transformation we're going through.